Chapter 10, Gases. Unlike liquids and solids, gases expand to fill their containers, are highly compressible, have extremely low densities. Pressure is the amount of force applied to an area, or P equals F over A. When we're looking at this diagram, we can see that atmospheric pressure, where we are in the classroom today, is 1 atmosphere of pressure. There are many different units that you can use to describe atmospheric pressure, which we'll explore in the coming slides. But basically, you can think of air pressure as a column of air over top of you that's pushing down on you. And again, atmospheric pressure is the weight of air per unit of area. So different units of pressure, we have pascals. A pascal is a Newton meter squared. We could also use bars. A bar is 100 kilopascals. We measure pressure using a barometer, like this pictured here. So being that a barometer is filled with mercury, we can measure millimeters of mercury, or torr for Torricelli, the man that invented the barometer. These units are literally the difference in the heights measured in millimeters of 2 connected columns of mercury. Also, you should note that 1 atmosphere is equal to 760 torr. So standard atmospheric pressure is 1 atmosphere, or 760 torr. There's another instrument that's used to measure gas pressure, and this is called a manometer. It's used to measure the difference in pressures between atmospheric pressure and that of a gas in a vessel. So in this particular vessel, we have a purple gas, perhaps it's iodine vapor, and you can see that it's exerting pressure on the mercury that's in that tube. The atmosphere is also exerting pressure on the open end of the tube, and because the liquid level is higher on the right-hand side, we then can extract from that the pressure inside the flask is greater than atmospheric pressure, because the pressure in the flask is pushing the mercury with more force. Also, we should note that the pressure of the gas is equal to atmospheric pressure plus the height difference. Standard atmospheric pressure. Normal atmospheric pressure at sea level is referred to as standard pressure, or sometimes we say STP. It's equal to 1 atmosphere, 760 torr, or millimeters of mercury. Another unit, 101.325 kilopascals, or 101,325 pascals. Another unit would be 30 inches, or 30 inches is equal to 760 millimeters of mercury. So you should become familiar with those units. And to practice that, I have a sample exercise 10.1, converting between units of pressure. So this problem asks us to convert 0.357 atmospheres to torrs, 6.6 times 10 to the negative 2 torrs to atmospheres, and 147.2 kilopascals to torr. I'm not going to read through this entire problem because you can see the work and it's obvious the math is very simple. We're using factor labeling or dimensional analysis, whatever you want to call it. In the first problem, we're using a conversion factor that says that 1 atmosphere is equal to 760 torr. Again, you should become familiar with standard atmospheric pressure in several different units that are outlined in your book. So here we have atmospheres converted to torrs. In this conversion factor, we're doing the same thing, same conversion factor, only to cancel our units, we just flip-flopped it upside down. And then lastly, we're converting kilopascals to torr with the equality 760 torr is equal to 101.325 kilopascals. So you can try the practice exercise by yourself. It says, in countries that use the metric system, such as Canada, atmospheric pressure in weather reports is given in units of kilopascal. Convert a pressure of 745 torr to kilopascal. An English unit of pressure is sometimes used in engineering is pounds per square inch, or PSI. Another factor that you should commit to memory is that 1 atmosphere is equal to 14.7 PSI, or pounds per square inch. If a pressure is reported as 91.5 psi, express this measurement in atmospheres. Sample exercise 10.2, using a manometer to measure gas pressure. On a certain day, the barometer in a laboratory indicates that the atmospheric pressure is 764.7 torr. A sample of gas is placed in a flask attached to an open-end mercury manometer as shown in figure 10.3. A meter stick is used to measure the height of the mercury above the bottom of the manometer. The level of mercury in the open-end arm of the manometer has a height of 136.4 millimeters, and the mercury in the arm that is in contact with the gas has a height of 103.8 millimeters. What is the pressure of the gas in atmospheres and also in kilopascals? So we're given the atmospheric pressure, 764.7 torr, and also the two heights of the mercury in the two arms of the manometer. We're asked to calculate the pressure inside of the flask, or the pressure of the gas in the flask. We know that this pressure must be greater than atmospheric pressure because the manometer level on the flask side is lower than that on the side open to the atmosphere, as indicated in the diagram. We will use the difference in height between the two arms, which we'll call h, to obtain the amount by which the pressure of the gas exceeds atmospheric pressure. Because an open-end mercury manometer is used, the height difference directly measures the pressure difference in millimeters of mercury, or torr, between the gas and the atmosphere. So we're taking the atmospheric pressure, which was 764.7 torr, and we are adding to that the height difference, the difference between the two heights in the manometer. We first get our answer as 797.3 torr. We then convert torr to atmospheres, and then atmospheres to kilopascal, because our question is asking for both atmospheres and kilopascal. You can try one on your own, converting a pressure of 0.975 atmospheres to pascals and kilopascals.